Hello everyone, myself Nijeesha, Assistant Professor of Computer Science Department in Emmanuel RSR JJ College of Engineering, Natalam. Now I am going to teach about architecture of 8051 microcontroller in subject Embedded System and IoT. First we have to see what is microcontroller. A microcontroller is a small electronic device that contains a processor, memory and input-output ports all in one unit, and it is designed to control specific tasks in embedded system. The 8051 microcontroller is an 8-bit microcontroller developed by Intel in 1980. It is widely used in embedded system for control-oriented applications. Next, the features of 8051 microcontroller. What are the features comes under 8051 microcontroller? It is 8-bit data bus, 16-bit address bus, 4 KB on-chip program memory, that is ROM or EPROM, 128-byte on-chip data memory RAM, two 16-bit timers, timer 0 and timer 1, T0 and T1, 5 interrupts, 3 internal interrupt and 2 external interrupt, 4 parallel ports, each of 8 bits, port 0, port 1, port 2 and port 3. The total of 32 input-output lines. One 16-bit program counter and one 16-bit data pointer. 32 general purpose registers, each of 8 bits. One 8-bit stack pointer. 1 microsecond instruction cycle with 12 MHz crystal. One full duplex serial communication port. These all comes under features of 8051 microcontroller. Next is block diagram of microcontroller. A microcontroller is a highly integrated single chip which consists of on-chip CPU, that is central processing unit, RAM random access memory, ROM read-only memory, IO unit, that is input-output ports, serial communication port, timers or counters and interrupt controller. These all are comes under 8051 microcontroller in block diagram. In this we are going to discuss about the main block is CPU, central processing unit. What is the function of CPU? The CPU can perform arithmetic and logic operations on data. What is arithmetic and logic operations? The arithmetic operations are, it perform addition, subtraction, multiplication and division. Then the logical operations are OR, NOR, XOR. These all are comes under logical operation. Both are done in arithmetic logic unit operations. Then it is 8-bit CPU and it perform addition of two 8-bit data. Same way it perform the logic operation also. In arithmetic operations, the 8-bit of two 8-bit data in addition, subtraction of two 8-bit data, multiplication of two 8-bit data and division of two 8-bit data. And same way it can perform logic operation also. The complement of two 8-bit data in NOR operation, complement of two 8-bit data in OR operation, XOR operation, etc. This is all about CPU. This now CPU is not store any data. So that purpose we have to connect read-only memory. And read-only memory is a permanent memory, that is ROM. It is a permanent memory and it is used to store the program. In 8051 we have totally 4 input-output ports. The ports are P0, P1, P2, P3 and these are bidirectional. In that we have transmit 8-bit data and receive 8-bit data. Both are in 8-bit data. Then P0 is act as address bus or data bus. In CPU, it controls all operation and execute instruction. Arithmetic logic unit, it performs mathematical and logical operations. Registers are temporary storage registers, that is accumulator, B, PC program counter register, SP stack pointer register and PSW. RAM, data memory, it stores variables and temporary data. ROM is program memory, it stores the program or code. I/O ports are 32 pins and it is used to connect external devices. Other pins are external pins. Timers or counters, it is used for delays and counting events. Serial port, it enables serial communication like transmission and receive. In transmit, that is TXT, receive the data is RXT. Interrupt control, it handles external or internal interrupt. Oscillator or clock provides timing signal for execution. Next is architecture of 8051 microcontroller. In this architecture of 8051 microcontroller, first we have to see is program counter, that is PC. Program counter is a 16-bit registers and it stores the program memory address of the instruction presently being fetched. Unless the program flow path changes, increments to the following instruction constantly. DPTR stands for data pointer register. This is also a 16-bit register and stores external data memory address. In a 16-bit register, store external data memory address of data and being fetched. And A is accumulator. Accumulator is 8-bit register that is used to save an operand for arithmetic logic unit or data transfer operation, as well as for storing result after an ALU operation. B register is 8-bit register for storing a second operand for the ALU, as well as accumulating the result of an ALU operation for multiplication or division. In PSW is processor status word, a register to save the bits of different flag. Here 4 ports are there. Each port has 8 bits, that is P002 to P07. These are port into port drivers, port latches. There are 4 drivers and 4 latches. Then port 0, 8-bit port acts as a data bus for I/O in a single chip mode and lower address expanded mode. Port 2 is 8-bit port, act as data bus for input output in a single chip mode and the higher order address in expanded mode. Port 1 is also 8-bit port, act as data bus for I/O in a single chip mode and a few device operations related bits in certain 8051 family variants in expanded mode. Port 3 acts as a data bus for I/O in a single chip mode and serial interface bits, timers T0 and T1, interrupt INT0 and INT1 input, RD and WR for memory read and write in the expanded mode. Then SA is serial interface device. It contains RXT and TXT in port 3, that is in serial communication mode. T0 and T1 is timer 0 and timer 1, timing devices in 8051 family using 4 registers, that is TH1, TH0, TL1 and TL0. Then ROM, read-only memory, has masked ROM, EPROM or flash EEPROM of 4 kilobyte is available in 8051 classic family. And internal RAM, that is internal random access memory, for read and write 128-byte memory is indirectly and directly addressable in address space. Register banks are 4. There are 4 sets of registers, each of 8 registers, and these are also part of internal RAM. XTAL1 and XTAL2 pins, these are the crystal pins. These pins are in the oscillator circuit, usually 12 MHz. Then EA. EA means external enable, to enable use of external memory address to external ROM. RST means reset pin, reset circuit input and also reset few output cycles to the external peripheral devices to let processor reset and synchronize with devices. In integer 0 and INT 0 and INT 1 are interrupt pins. There are 2 interrupt pins. These all are 2 external interrupts, that is active low. VCC and GND is voltage supply. This VCC voltage is 5 volt supply and ground connections. These are the 2 pins, voltage pin and ground pin. Then PSEN, that is program store enable. These pins are active low when reading the external program memory bytes. RD means read. When reading the byte from external data memory, the pin will become active low. WR means write. When writing the byte to external data memory, the pin will become active low. In PSW register, it contains several bits and reflect the current state of this CPU. Here, CY is carry flag, AC means auxiliary carry flag, F0 means flag 0 available for general purpose, RS1 is register bank selector bit 1, RS0 register bank selector bit 0, OV overflow flag, P parity flag. If the parity flag is set, it cleared by hardware in each instruction cycle to indicate an odd or even number of 1 bit in this accumulator. In register bank 0, the address is 00H to 07H. H is hexa. If register bank is 1, the address is 08H to 0FH. If register bank is 2 means 10H to 17H. If the register bank is 3 means 18H to 1FH. Finally, the special function registers. In this SFR register, the address ranges 80H to FFH. Only 21 SFR in a typical 8051 family. And it is important of 8051 microcontroller that is categorized into 21 special function register, each in 7 groups. In CPU register or math register, that is A and B registers. Then PSW status register is program status word, that is PSW. Then pointer register is DPTR data pointer, and stack pointer is SP. IO port latches, input output port latches P0, P1, P2 and P3. Then peripheral control registers PCON, SCON, TCON and T mode, IE and IP. PCON means power control, SCON means serial control, TCON means timer control, T mode na timer mode, IE means interrupt enable, IP means interrupt priority. Peripheral data registers TL0, TH0, TL1, TH1 and S buffer. In this power control 8051 microcontroller, the power modes are controlled by PCON and this address is 87H. The microcontroller can set to operate in idle mode or power saving mode using 2 bits. In serial control, the address is 98H and it is located in 98H. We can control the serial port operation modes, baud rate and ability to send or receive data using the serial port using SCON. In timer control we are started or stopped using the timer control. Additionally, it has bits that show whether the timers have overflowed. In timer mode, the operating modes of timer T0 and T1 are set to T mode, and timer mode register is timer 0 is configured using lower 4 bit and higher 4 bits are used to configure timer 1. If timer is T0 and it is a lower 4 bit, and if it is T1 it is higher 4 bit. IE means interrupt enable. If the interrupts are enabled or disabled using this IE or interrupt enable register. If the enable of the bit is set, the matching interrupt is enabled, and it is disabled if the bit is cleared. If it is set and it is enabled and it is clear if the bit is disabled. All interactions or all interruptions are either enabled or disabled using bit 7 of IE register, and it is known as EA bit. Then IP is interrupt priority bit. Here it can be adjusted to high or low using the IP or interrupt priority register. If the bit is set, the interrupter is given high priority, and that means it is set. If it is cleared, the interrupt is given low priority. This is all about interrupt priorities. This is about 8051 architecture of microcontroller. Thank you.